Sustainable tillage practices that promote soil health are critically important to the long-term viability of farming. This poses a challenge for many commercial vegetable farms in the Northeast, where a lot of tillage is used to prepare seed beds, control weeds, and incorporate residues. This video explores a variety of tools and techniques that growers and researchers are using to reduce the intensity of tillage while maintaining crop production. Farmers can decide for themselves what practices best fit their operation.
In the past 50 years or so, we've focused a lot of our attention on the chemical functions of the soils, and we've established a good infrastructure for soil testing and providing advice to farmers about the chemical functions of the soils. But the physical and the biological functions have not been developed very well. And as a result, we've seen many of our soils have become physically and biologically degraded. Farmers have a real challenge with managing the physical and the biological health of the soils, because traditionally tillage is a very integral part of the cropping system. Yet we now know that tillage also has a strong negative impact on the health of the soil, and certainly if tillage is repeated year after year for many decades, we see tremendous degradation of the soils. So we need to focus on finding alternatives to traditional tillage systems to build up those soils again and make them productive for our crops. Tillage affects soil health in a complex way. On the short term, tillage provides benefits by loosening the soil and allowing for water infiltration and oxygen to enter into it. In the long term, however, repeated tillage oxidizes organic matter that's critical for soil aggregation and structure. And so what we see after decades of repeated intensive tillage, that the soil degrades and becomes dense and compacted. The Moultonboro plow has been used for centuries to invert the soil. It's a very effective tillage tool, but it also breaks up soil aggregates, oxidizes the organic matter, which is critical to good soil aggregation. It also causes plow pens that reduces root proliferation into the subsoil. The rotavator is a tool that does an excellent job of creating a seed bed, and it has been used in vegetable systems for that reason. The concern about the rotavator is that, like the Moultonboro plow, it's a very intensive tillage tool, and in the long run it causes the destruction of soil aggregates. The disc harrow in a way performs less intensive tillage, which is good, but it has one particular problem, that it causes a lot of pressure at the bottom of the discs, especially when it's offset at a wide angle. And this causes some compaction that results in what we call a disc pan. To build healthy soils, we need to use good management practices, and I look at it as a balance sheet. Tillage and intensive monocrop production are practices that reduce the health of the soil. They degrade the soil. Other practices like cover cropping, good rotations, especially those including sods and legumes, and the addition of organic matter like manure and compost help build the soil. In general, what a farmer wants to achieve is a good balance between those practices. One of the interesting things that we found is that these soil building practices can also mutually reinforce each other. For example, combining reduced tillage or no tillage with cover cropping enhances the benefits of both.
I'm Jean-Paul Cortens. We're at Roxbury Farm in Kinderhook, New York. It's a 250-acre farm. We've been here since 2000, and we bought it from a potato farmer.
I'm Jody Bolluyt, and each season we have 40 acres in vegetables and 40 acres in cover crops, different grasses and legumes, so that we can have a good rotation. We grow for our 1,000-member CSA, and we deliver from New York City all the way up to Albany. And each season we grow a wide variety of vegetables. We also include some strawberries and some herbs.
Well, our goal here is soil health, and soil health to produce healthy cash crops. In order to do that, we need to till the soil. We cannot do no-till because it's too cold where we are. We need to expose the soil. And in the process, we're aerating the soil. We incorporate our cover crops for nutrients, and we create a seed bed.
Because we're an organic farm, we have to get most of our nutrients from our cover crops and our compost. So before we till for our vegetable crops, we'll either mow some of our cover crops that are really lush, like sweet clover, red clover, or hairy vetch, and then we'll spread 20 yards of compost to the acre. For winter-killed oats and peas, we don't need to mow, so we just spread the compost and then we'll spade that in.
In our rotation, we're growing 2 years of cover crops. That is followed by 2 years of cash crops. In order to prepare land for our cash crops, we're using a spader. And we chose a spader because it minimizes passes, and we are able to incorporate a full standing cover crop almost immediately before we plant our cash crops, therefore minimizing inputs from other sources. Okay, so this is the spader. It consists of two components. In the front, there are the spades themselves that are mounted on a rotating axle, and they move around in relatively slow speed and grab big chunks of soil and invert that deeper down. Then it's followed by the power harrow, which is also relatively slow moving. And these tines here, they push the larger chunks of soil deeper into the soil. Along with that, the debris, the plant debris in the soil. So what happens here by moving that further, pushing that further into the soil, it will be able to decompose. Then when we come back a week later, we are not dealing with the dried up plant debris that can clog up our seeders. So the action of the spades is actually very slow compared to, say, a rotavator. A rotavator moves at high speed and it would destroy the aggregation of the soil. What it does, it leaves the soil in very large clumps. This is like one clump where you can see that not a lot of damage has been done to the natural structure of the soil. So the whole idea is that we want to have an inversion, we want to incorporate, but we don't want to destroy the aggregation. And this is possible with the action of the spader. This field was spaded a week ago. The hairy vetch was worked in, and the hairy vetch has been starting to break down. And when it is broken down, which can take anywhere between 1 week to 2 weeks, depending on the warmth of the soil, we start making beds.
I'm Ed Person from Ledgewood Farm in Moultonboro, New Hampshire. The farm consists of 100 acres, 22 are tillable, and we sell at a farm stand on a busy road. I use cover crops on all my fields. I plant them in the fall. The oats winter kill, and the winter rye is a green residue in the spring for those fields that I can't get on until later in the spring. We used to use moldboard plows and a rototiller to do all our fields. Very small residue. We used a Planet Junior planter, so we had to use a system that had very little residue. Then as I changed planters, we were able to go to a reduced tillage system, which includes a chisel plow and a Perfecta field cultivator. This field that we're standing in here is winter-killed oats. I prefer those over winter rye because it does leave a dry residue in the spring. There's enough residue to keep the weed pressure down, but with this amount of pressure, I'm still able to till the way I want to. We plant the oats at about 100 pounds per acre, and we broadcast them with a spin spreader, and then we use the Perfecta to turn them under at about 2 inches deep. The weed pressure that's left here is not a problem for us. These will incorporate very easily. If there's a lot more weeds, then we will mow it so that the length of the weeds doesn't tangle up in the chisel plow. This is our chisel plow. We converted using this about 20 years ago. Before that, we moldboard plowed and harrowed, and then we moldboard plowed and rototilled as the rotavator or rototiller became more prevalent. This saves us a lot of time, and it reduces the fracturing of the soil, or the beating up of the soil, I guess is what most people think of when you rototill. This is a set of chisels that go in the ground about a foot. They'll make a furrow that tills the soil about 12 inches wide. The shanks are 12 inches apart, so the entire field gets tilled. After that happens, these smaller spring points will make it so that the big furrows are wiped out or smoothed over. And then the rake on back smooths it out so it's almost a perfect seed bed, but it's still a little too coarse to plant in. This is our Perfecta that we use for our final tillage after we've either used the chisel plow or the moldboard plow if there's a lot of trash that the chisel plow couldn't handle. This is the same principle as the chisel plow. We have a set of aggressive tines in the front that are spaced about 4 inches apart, and they will fracture the soil more than what the chisel plow did. Then we have another rake that will flatten the ridges that the chisels make, and will also aerate with these slanted tines. And then after they have passed, a roller is the next in line, and that packs and textures the soil so that it will stay in place and we can plant into it. This brand is a Perfecta by Unverferth. There are many other brands out there that you could buy. We use a heavy-duty S-tine and a 7.5-inch shovel. You could also get it in a lighter S-tine and a narrower shovel. We use this particular setup because of our heavy soils and the rocks that we have to bounce around. This is what we'd like to see after the Perfecta is finished. A little bit of texture, some trash that's scattered in between, but my planter will certainly plant into this without any trouble. Over here, this is a little too trashy, but the planter will still work, but it may be hard to cultivate later. This is a Mattermack air planter. We went to this a few years ago from using our Planet Junior and our 71 Flexiplanter because it allows us to plant in heavier trash. And using the chisel plow and the Perfecta, which are really fast tools to prep the soil, this is the next step in doing that. The concept is it has fertilizer hoppers, seed hoppers, which are the same as any other planter. And then when we get down to the working unit, there's a shovel that clears the trash out of the way, a set of discs that opens the trench, and then another set of discs that presses the trench closed with the seed in it. So it really moves the trash out of the way, and we can plant in really tough going. This is the plow that actually moves the trash and the rough ground out of the way for the discs so that they can set the seed at the proper depth. 1/2 inch for carrots and beets, for example, 2 inches for the corn and beans. These are the drive wheels. They actually turn the gearing that allows the seed plate to turn and dispense the seed at the right locations. The vacuum holds the seed onto the plate until it's ready to be dropped. The openers are these discs that are hidden inside. They will cut the furrow. These wheels maintain the depth. These two wheels are the covering mechanism. They're angled so that they put pressure with the spring to cover in the furrow. The benefit of these press wheels, rather than a shovel to cover the seed, is that they can work through the trash, and they can also get the clods to just press in rather than having to move them around. Any planter that has the ability to move trash will work. I happened to buy a Mattermack because the price was right, and it was a unit I had seen actually working.
I'm Jay, my wife Polly, Armour. We farm here at Four Winds Farm in Gardiner, New York.
We have a 24-acre farm, of which about 4 acres is in a market garden. We sell primarily through a 30-member CSA and at 2 regional farmers markets. When we started farming here in 1988, we used conventional tillage, plow, disc, rototill. And about 10 years ago, through a serendipitous relationship with a local not-for-profit, we figured out a way to do no-till farming, raised beds on a large scale.
We farm 4 acres of vegetables without using a rototiller. We put compost on top of permanently formed beds, and we plant right into the compost. Some crops we plant directly into the compost, things like lettuces, beets, carrots, parsley, various herbs, basil. Some of the crops that we plant, like the transplants, your tomatoes, your peppers, your onions, leeks, we plant the transplants right into the compost. After doing it for a number of years, that we've seen less weed pressure. We have a lot more free time during the summer. We end up spending more of our time actually just harvesting than we do trying to deal with weeds, and a lot more relaxed environment.
The first section of the garden we converted to raised beds. We did sort of the backyard garden way using a shovel. After that, we figured a way to use a tractor-mounted adjustable back blade that then was able to convert large parts of the garden on, acres at a time into raised beds. And that has allowed us to convert, a 4-acre garden into permanent raised beds.
Coming from a conventional background, I had a hard time adjusting to the idea that we don't need to till every year. But as long as you don't walk on the soil, or you don't drive a tractor on the soil, you don't compact the soil, it will stay nice and loose. And you can get away with not tilling year after year after year.
We're adding a great deal of compost onto our fields, at least initially, and you might think that that's going to add to the weed burden, but since it's composted manure, the weed seeds have been killed during the composting.
And what we're doing in the garden is we're covering up the soil that has the weed seeds in it. We're putting a layer, sort of a blanket of compost that doesn't have a lot of weed seeds in it, and we're sealing that off so that we have a much lower weed pressure here. The one weed that we do have a problem with is dandelion, because the seeds blow in rather than are there naturally.
Sometimes other airborne seeds will come too. Thistle, milkweed, but those usually aren't a problem if you can get on them right away.
During the wintertime, our cows and sheep stay up here in the barnyard. Since they're up here, we're able to collect their manure, and this time of year, in the springtime, I come in with a tractor, we dig out the manure that's collected in the barn, and we pile it up into this pile here, mix it with horse manure that I bring in from another farm. The cow manure is just a little too heavy, a little too wet to get generating any heat. So mixing it with the horse manure will give us that heat that we're looking for. This is a pile I made a couple of weeks ago. We can just put this thermometer right on in here and check the temperature. It's something I do every day, just to monitor the temperature. After the manure has been sitting in for about 5 months, I load it into a rear discharge manure spreader. That helps mix it up, aerate it, and pile it up over here. It will sit here for about 6 or 7 months during the course of the winter. The following spring, we use it as finished compost. It goes right onto the garden.
Here's one of our raised beds that hasn't been tilled in 5 years. And you can see how light and fluffy it is. I can put my hand right into it. The soil maintains good tilth. And as easy as I put my hand in, the plants can put their roots right down. This last got compost last spring, a year ago. We're not going to put any compost on it this year because it doesn't need it. In the beginning, when we first started doing this, and also when we first turned over new ground, we put on a lot of compost, sometimes a couple of inches thick. But since then, we've really cut back. We found we don't need as much in subsequent years, and also we don't want to put too much compost down because that'll increase the amount of phosphorus we're putting onto the soil.
My name is Anu Rangaranjan. I'm in the Department of Horticulture at Cornell University, and we're here at the Homer C. Thompson Vegetable Research Farm. We are doing some research here on trying to figure out how to reduce tillage in vegetable production systems for the Northeast. And so we are focusing on primarily zone tillage systems because we think they're the best for our conditions in the upper Northeast where it's cooler. In zone tillage, we're only disturbing about an 8-inch band of soil across the whole field where we're going to be planting. You can work that zone fairly shallow in sort of traditional zone tillage, which is a 3 to 4 inch depth using a set of coulters, or we can work deep. And we'd be wanting to work deep where we have fairly deep, where we have some compaction layers that we want to break up. This is our zone builder. It is made by Unverfirth, and there's other types of zone builders available from other companies. This requires about 30 to 50 horsepower per shank and a tractor with a high clearance hitch. In front you have a set of cutting discs that cut through residue in the soil. Following that is this deep tillage shank. This shank is a very hardened steel that allows it to travel 12 to 18 inches deep even in the soil. But behind that it's followed by hilling discs. These actually hill up the soil and create a mound that creates a very nice planting zone, and then these rolling baskets break up any clods in the soil. So zone tillage is an improvement over conventional tillage because you are only working a narrow piece of ground. Using an implement like this, it allows us in one pass to prepare the planting area for a particular crop. And we've done this with a lot of large seeded vegetable crops, including sweet corn and beans and pumpkins, which are the most popular vegetables right now to do in zone tillage. And we're also exploring transplanted crops such as peppers, tomatoes, and cabbage. In the future, we hope to be able to do this also with root crops and smaller seeded crops. It's a big advantage over conventional tillage because here you only make one pass. You don't have to plow a disc. The advantages of that is that you conserve fuel, you conserve time, and you enhance soil quality by not inverting the soil. Here we're demonstrating the zone tiller in a Sudex cover crop. We've used it in a killed cover crop as well as a living cover crop because it's quite aggressive and it can handle that type of residue. Zone tillage doesn't require fancy equipment. We started out with this fairly simple tool which involves 3 wavy coulters that create that shallow zone mounted on a toolbar. And we have them spaced 30 inches for our crops in the way we plant here. We make the decision on how deep to run our deep tillage based upon soil compaction, because that deep shank that you saw it's important that that runs just below a compaction zone. So it's important to have a penetrometer in the field with you when you start doing this type of work.
My name's George Ayres. My wife and I are partners at Fresh Air Farm in Farmington, New York. We farm 550 acres, about 100 acres of vegetables, sweet corn, pumpkins. We grow about 5 acres of small fruit that we pick, and the rest of the farm is small grains and hay. We moved to this farm in 1988, and the tillage system was mostly moldboard, plow, and chisel. And I was concerned about the quality of the soil, the amount of tillage I was doing, the drying. It dried out so much in the spring. And when I began to see zone till introduced in this area, I became quite interested in it, and it solved 2 problems that I'd had with no-till when I tried it. One was to get the seed slot closed and get good germination, and the second problem was how to put fertilizer down with that seed with no-till. And the zone till, you're tilling a little strip about 6 inches wide every 30 inches, and the area in between is not tilled. So the planter and the fertilizer equipment works like it was intended, and the area in between doesn't grow weeds because you're not tilling the soil. And it's really worked well for me. And so we've gradually worked through the farm until now the whole farm is, everything we grow is zone till. This is my 2-row zone builder that I built a couple of years ago for our strawberries. I started with a commercial unit that's 4 rows or 6 rows wide. I needed a small machine for the berries because they're on 48-inch centers, and the commercial machine is 30-inch centers, and it's so big that it's very difficult to move. So this was a project just for our strawberries. This was originally a toolbar that was 15 feet long, and I cut it in thirds. I bought 2 channel irons and just welded the frame. The hitch, of course, was already there, so I already had it. It was an old toolbar that used to be on a rotary hoe that we don't use anymore. These 2 shanks were from a chisel that I don't use anymore. I bought years and years ago, and I took 2 off once to make it a little smaller, and they just were, you know, around, and so they just fit right on this. These parallel linkages are rejects from the commercial zone builder that I had. I changed it a little bit, and I had 2 of these left over. These can be purchased from the company that built the zone builder. We made the brackets, put it on here, and then I just steal these coulters, these 13-wave coulters from the commercial zone builder. I put them on here when I'm doing strawberries, and I take them off and put them back on that machine when I'm doing my other work. So I did not buy these. You could, but it doesn't take very long to change them. This thing goes about 12 to 14 inches deep. The discs just form the ridge right up over the slot. The key to the zone builder, whether it's this one, a commercial one, or whatever you do with zone tillage, the key is to do vertical tillage, not horizontal tillage. We don't want the tool that you're engaging in the soil to be pushing the soil sideways, like a moldboard plow, a disc, a field cultivator with sweeps on it, because that's where you get a compacted layer, right where that shearing action is from that sideways motion. Everything on this thing and with zone tillage is a vertical form of tillage. It doesn't have any sideways shearing. That's the key.
My name is Erik Buzby of AT Buzby Farm, Woodstown, New Jersey. We grow 125 acres of fresh produce. We've been experimenting with no-till as a way to conserve our organic matter and help build our soils and protect against erosion. In this area we have light sandy soils that tend to blow early in the spring, and for 20 years we've been using this annual ryegrass as a way to protect our soils against that. We started thinking about going to no-till as a way to help conserve our soils, to further prevent wind and water erosion, and to help try to build our soils' organic matter levels. This is a field of annual ryegrass that was killed 3 weeks ago. Earlier in the season, we try to wait as long as we can before we kill it, because if it's young and tender, it doesn't last as long as a mulch. In another week, we'll come in and spray this with Roundup again to kill any weeds that are starting to germinate and emerge, and then we'll plant into it a week after that. Or some of this we're going to save probably for another 4 weeks. This will last the rest of the season. We don't have to worry about it decomposing before we need it. As long as you have enough residue, you can plant a week, 2 weeks, a month later. It's going to last, and it's going to be an effective mulch as long as you have this kind of residue. We found that it's important to mow this grass early in the season. When it gets about a foot tall, we cut it back down to 6 inches. Do that a couple times. That helps promote root growth, and it also limits how much vegetation you get on top, because if you get too much, it actually gets difficult to plant into. So we just use a rotary mower and come through here a couple times and cut it off. In the future, we're thinking about trying a flail chopper to more evenly distribute the clippings. This is our Holland transplanter that we modified for use in this no-till situation. We put this tape shoe on the front, which consists of a couple coulters to open up a ditch, and then these packer wheels, which pack in the dirt behind the tape. It makes it a lot easier to put in the tape while we're planting. That way you get consistent spacing between the tape and the plants. This is a benefit of having our sandy ground though. This will go into the ground. In heavier ground, I would be concerned that it wouldn't work. The other modification that we made to this planter is that we added these no-till packer wheels to the back to pack in around the plant. These put more pressure to move this dirt, which isn't quite as soft as it is if you have a plastic mulch. And you have to add this weight too. These were transplants that were set 2 weeks ago. They were set into this grass that was killed twice with the Roundup. And this residue, although it helps repress the weeds, isn't enough to totally control for the whole season. So what we do is, after we've pruned the tomatoes and before we put the sticks in, we'll come back with a selective herbicide that helps control the broadleaves for most of the season. I wouldn't say that we have this no-till system perfected. We still have problems, and I think that we have more questions than we have answers, but I'm encouraged by some of the things we see, and we're gonna keep trying and making mistakes, and hopefully we'll get better.
My name is Chuck Mohler. I'm a researcher at Cornell University in the Department of Crop and Soil Sciences. I'm working on an organic cropping systems project funded by USDA. This is a ridge till system for vegetables we're trying to develop. These ridges were originally built 2 years ago. Since then, they've been scraped down and reformed several times, but the idea is that we keep the wheel traffic in the same lanes all the time, and that allows the bases of the ridges to develop good soil structure by earthworm channels and dead root channels. That improves the ability of the crop to root and improves disease management. It doesn't look like much now, but 3 weeks ago in mid-June, these ridges had vetch about that high all over them. We flail mowed the vetch. About a week later, came through and scraped off the tops. That mixed the soil in with the vetch a little bit, helped speed up the decomposition. A week after that, the ridges were reformed. We're now ready to scrape the ridges again and plant cabbage. The reason we scrape and reform the ridges is to get the vetch incorporated so that it can decompose, and also to maintain good weed management so that the weeds are relatively under control. This is our ridge scraper. It's made by Suckup. They don't make them anymore, but it's fairly simple design. There's these canted wheels keep the scraper on the ridge. Then we've got a double coulter here that cuts through any residue. And finally, this snow plow arrangement scrapes the soil off to the side. The parallel linkage here holds the implement at a constant depth. The adjustment is up here in front. You can adjust it up and down by setting these 4 bolts into different holes. The goal is to scrape about 2 to 3 inches off the top of the ridge.
I'm Ann Nordell, and this is my husband, Erik. We've been farming here since 1983 in the village of Beech Grove, Pennsylvania. Our farm is about 90 acres, but we're mainly farming about 7 acres under cultivation, managing for vegetables. We supply locally to Williamsport, Pennsylvania, which is about 25 miles away. We do a farmer's market once a week, and we supply restaurants and grocery stores.
One of our goals when we started farming here was to keep this a two-person operation. And also we wanted to rely on horsepower completely, not only for tillage, but also for fertility. So that limits our labor, our power, and our fertility source. And consequently, we rely on cover crops extensively. In fact, we take half of the land out of production each year just to grow cover crops. This has helped tremendously with weed control, maintaining the tilth of our silt loam soil, as well as preserving moisture, which is an issue for us because we don't have irrigation. One reason we got into reduced tillage is really to optimize the benefits of the annual cover crops. Intensive tillage can also often destroy everything we've gained, so by minimizing the depth and intensity of tillage, we can preserve more of those benefits. Becky, Ben. We like to use the horses for several reasons. First of all, I just love working behind the horses. That's what gets me going, sustains my interest. They also save the fossil fuel and pollution associated with that. And of course, there's less problems with compaction and so on. You could take anything we're doing here and do it with a tractor, probably with fewer passes and maybe a lot less aggravation. It was about 10 years ago that we started experimenting with reduced tillage using this ridge till system. For years before that, we'd been using a winter-killed cover crop, just working it into the surface of the soil for early planted vegetables. That worked great for conditioning the soil, erosion control, moisture preservation, but it was a problem in springs when it was cold and wet. So we started planting the cover crops on these ridges. It allows the soil to warm up and dry out faster in the spring. It also enables us just to peel the top off the ridge, moving the cover crop residues into the pathway. If there are any winter weeds on the ridge top, it also sheds them into the pathway where it's easy to control them with mechanical cultivation. One of the differences of doing this kind of minimum tillage with the horses is we have to break it down into several steps. With a tractor, you could do all the ridge building steps in one pass. I simply don't have the physical strength to raise and lower that much equipment on the old riding cultivator, so we do it in 3 steps. After broadcasting the seed, we build the ridges, then we come back, interseed the pathways, and then the final step is to roll the ridges with a cultipacker. The idea is we want to kind of level them, make a nice flat seed bed, and also to create better seed to soil contact for the cover crop seed. It helps bring the moisture up to germinate it. Typically we plant oats like you see here, and the peas coming up. This makes a nice mix of a small grain and legume. In this planting we also have sorghum Sudan grass to boost the carbon and cover crop biomass. These steps we use for preconditioning the beds for planting in the spring. The residue cutter chops the residue. It also makes those slits in the soil. It kind of hairpins the residue in. So then we can go over with this rotary hoe and just lightly till the surface of the soil. This makes it possible for us just to make a furrow for transplanting. We'll just go right into it, or we'll scrape the top off the ridges for direct seeding. It probably looks like these tools aren't doing much, but that's really the whole point. We're just trying to loosen the top inch of the soil. The residue cutter slices the residue. It also cuts about 1 inch deep in the soil, and then the rotary hoe loosens that up. You can see we have this sort of crumb mulch on the surface. When we peel this back to plant, we'll have a nice seed bed for planting.
Here's a field where crops have been planted into our ridge till system. The previous fall, we built the ridges and planted a cover crop of oats and peas, and then they winter killed. They die back. In the following spring, what we did was we go through with the residue cutter to cut up the residue, and then we went through with the rotary hoe to kind of loosen up the beds. And then all we did was we made a narrow slit in the soil and then planted the transplants of onions and leeks. Because the residue breaks down so fast, it doesn't really provide weed control or moisture control. So what we do is we put down wheat straw in the pathways in order to preserve moisture. But the weeds have not been a big problem here. We haven't done any hand weeding in this field at all.
Crops. How about that? Is that out?
Great.
Yep.
That's great. Is it worth doing?
Don't mess with that one, Groupman Jack.
And try not to say any ums.
The ums.
We could, it's not a big deal, but
Yeah.
you'd rather not see yourself later saying it.
Give it a shot.
Well, I'm excited because he's here now.
That's
so.
right. He's an exciting guy. We're near you're ready.
Okay, you can brush your hair too, just so you
Oh, is it?
haven't been at work. There you go.
I mean, it's wet.
Camera's not really even.
Yeah, I was
Okay,
looking at the
camera's
camera.
not
but-
there.
Yeah, just look at Vern. You want to move forward a
Just
little
tell
bit?
me,
It's easier.
Bug here.
And you'll get that straight 24 acres. Mark.
Is it nice? Nice scene there? Okay. So tell me when I can start.
And I gradually worked the whole farm, and now with the strawberries, the last couple of years, we've zone-tilled strawberries. Everything we grow is zoned.
That was a lot, but really good.
I should say some years
A couple
ago.
years ago.
Yeah.
A few years ago.
Don't date it.
Yeah, because
In 2020 when they're watching this.
Right.
The scraper on the ridge, these are sorry.
I can't do this.
It is
Let me
strange.
start over again. Hi, Baron. How are you? Ready?
We're rolling. Oh, don't go too far. Get close there. Okay, ready?
So like I'm 10 years old. Hi, I'm
Yeah.